Ciao friends! In this video, we will see the differences between model-dependent functions and model-independent functions in DAX. This difference is important if you want to publish your code, the code of your functions on daxlib.org, or if you want to simply share functions in your company between different semantic models. Let's start with a demo. In order to explain the differences between these types of functions, model-dependent and model-independent, I will start creating a function, moving the complexity of a calculated column into a function, and then I will try to reuse this function from other models, conceptually understanding what is the problem of having a model-dependent function, which is initially good for the use within a single model. And then we will move forward understanding how to transform a model-dependent function into a model-independent one so that we can publish in a library, for example. And finally, we will see some nuance about what are the characteristics of a model-dependent or independent function. It seems easy, but sometimes there could be some details that are important and not so obvious. So we will see this in the second part of the example. Now, I prepared an example where we have the classic Contoso model, where we have our sales, store date, customer, product, which are the classic tables we have in Contoso, and we also have this table price range. This table price range is a table that conceptually is like an Excel file we import from a SharePoint folder, where business users, and ignore the definition we have now here, so the business user basically has imagine a table in Excel with these numbers. So we want to say, well, all the prices that are included in a certain range between 0 and 200, we want to classify them as very low. Then low, medium, high, very high. So there is a price range that corresponds to a range of prices. And we want to group the transactions according to this price range. So in order to obtain the report that you see here, where we have the range and the sales amount for each price range, we had to import this table that, remember, can be changed at any time by the user, and by just refreshing that table, we want to update the report. So the table size could be large, but we only have one calculated column in the sales table, this price range min column, that is used to connect the price range table. So by using min, which is the column that has the minimum value of the range and is a unique value, we connect the sales table. The sales table will keep this column hidden to the user, so we don't have to show this column to the user, and the user will only see the price range column. So we can also hide the min and max to the user this way. So basically this works, but how did we implement initially the price range min column in the sales table as a calculated column? So if we take a look at this definition, and remember, we are using a calculated column in this case because we want to make sure that as soon as I refresh this small table, the sales table is immediately available, so we don't have to wait for a complete full refresh of the sales table. So this is one technique that optimizes the execution, and as long as the table is 20, 30 minute rows, is basically fine. But we now have the implementation of this business logic in the code of the calculated column. The calculated column does the following. It retrieves for every row of the sales table the value of the sales net price, which is the column that we see here, net price. So let's say we get this 7516 value, and the following part is an iteration over the price range table, the table that you have seen before, looking for the row that includes between min and max the value that we stored in the variable current price. So current price is checked against all the rows of the price range table. The result is hopefully only one row here, and the value of the price range min column is returned by this select column. So price range min stores just the value of price range min that activates the relationship. So far, so good. It works, it's working, but imagine you want to reuse this code, the same code, in some other table. You want to implement this exact same code into another table, not about sales, about something else, for example, about other kind of transactions or purchases or something like that. Well, at this point, we have the classic two options. One option is that we simply copy and paste this code. So if we copy and paste this code into a table receipts, we will just rename sales net price into something else. But now we are duplicating a large amount of code. Or we can try to move this part of the code into a function we want to reuse. So the first attempt could be the following. Well, what if I get just this code and I create a function, right? So in order to create a function, now I can go to the model view, and by going in model functions here, I can use the user interface within Power BI to create a function. So new function, and I create my function. So here my function has a function name, ignore the error because at the moment we don't have a valid syntax, and we can start with a name that could be the price lookup. So we want to look up for this price value in the price ranges table. So this is a function that could have, I would say, one parameter. Remember, the code that we have is this one. This is the code that I copied from the clipboard. And the parameter we want to use is basically the price, or we could call it the search value. So I prefer to give a name to the variable that makes it easier to understand the role of that argument to people who call the function, but also internally to the function. So this could be the search value, the value we want to search, which could be passed by value. We don't need an expression that has to be evaluated internally, because basically this search value is like our current price here. So we replace search value here and here. We no longer have the need for a variable. And so basically now I transformed my definition of the calculated column into a function. And this function can be reused, at least in this model. Okay, so I click OK. My function works. So at this point, I can use this function by doing what? Well, I can go back to my definition of the calculated column, and instead of using this code that I comment just to be safe in case I made some mistake, I just invoke the function that I called, that I just defined, which is price lookup. Price lookup. Okay, price lookup. I have my search value, and the search value is sales net price. Sales net price. I want to search for sales net price, and as a result, I get again the same minimum value that connects the report, just to make sure that everything is good. This report is still working, which means that the value is still good. Just to make sure that I'm not lying, if I write here, for example, blank, right? Because I have a function that always returns blank, and I comment price lookup. You see that now this value is always blank as soon as I click this. Now price range mean is always blank now, and if I go back to the report, now everything is connected to blank, just to make sure that, yes, we have something that is working. So far, so good. So I created a function, and this function, though, is a function that I can only use in this model, in this Power BI file. Why? Let's take a look at the function again. So if I look at the function definition, so let's go to model price lookup here, you see that the function includes a table name, price range, a column reference, another column reference, same column reference again. So whenever we have a direct reference of an element that exists in the model, table name, measure name, column name, we call this function a model dependent function. So this is a model dependent function. What does it mean? Can I copy and paste this function into another model? Yes, I can. As long as I have a table called price range that has a column min and a column max. I can. Now the problem is that this function has a dependency, so it's a model dependent function. You can copy and paste this function, of course, but then you also have to be sure to create the corresponding table that is missing. You do that, it works. But of course, if you think about creating a function that is easy to reuse, that is easy to import and just use, having a constraint on the model could be too much. In case you have many models created based on the same template, that would be not an issue. But this is a choice that you can do internally to your company. If you want to share something on the internet, you want to share something to a large number of users, then some rule is necessary. And so we want to make sure that if we want to make it easy to use this function, we need to make sure that we don't have any dependency on the model. How can we do that? Well, the first step is that I can transform this function into a model independent function. How? Well, we have to remove these references to price range. So I could create a generic range lookup function that has all the references, all the external references as parameters. Let's do that. So let me I copy this function in the clipboard. I create a new function, and I create this new function that, first of all, will not be called price lookup, but it will be called range lookup, okay? Now, let's take a look at what are the dependencies of this function. So we have a table called price range. So this is a table. This is the table where I want to look for the value. So I would say that at this point, let me start to add the parameters here, and let's create the model independent function. And okay, after search val, I want to provide the table, right? I could call this price range table, but I prefer to use a name like lookup table. Lookup would be the table I want to search. Now, in this case, it's mandatory that the object I pass is passed by a reference, because only passing this object by a reference, I can make sure that I can use that reference in my expression. Now, in the specific case of the table, you could also provide a table by value, but in order to avoid problems with the following column references, my strong suggestion is that you pass this table by reference, which means that we provide any ref to say we want a reference, and this reference will be passed as an expression. So the parameter mode is by expression, by expr, not by val, by value. And at this point, a naming convention that we strongly suggest to use is to use a suffix for the parameter name, which is the type. In this case, this should be a table, so I call this lookup table. Okay, so lookup table says, okay, this is the table I want to look my data into, and so the lookup table would be here because this is the table I want to iterate. Now, of course, I need also more. I need also the column references. So we have a min column here, which is the column that has the minimum value. Now, this column must be part of lookup table, and I could write this into the documentation in some comment of the function. But basically, this will be a reference to the minimum column, and this is also a reference that we write as anyref exp. So we cannot express in a declarative way that this column should exist in this table. Okay, min column should exist in lookup table. Unfortunately, we cannot express this. Hopefully, in a future version, we will have a way to say that, because this would be you know, will make it declarative, the fact that there is a constraint, because we assume that this column exists there. Same for max column. I can copy and paste this part, so it's a little bit faster. And I use max column here. And finally, you see that I was returning price range, and so min column is the result here. Now, this is exactly the same function I wrote before, but I removed any direct reference to the model into using generic references that are parameters of the function. The function now is a model independent function. Yes, I can now copy and paste this function into another model, because I know that there is nothing in the other model that is needed to make this function work, as long as I provide parameters that are compatible. But it's easier to understand from the parameters, from the description of the parameters, from the documentation of the function, what you are expected to do with these parameters. Now, this is what we say is necessary to publish a public library. Okay, so if you want to use, let's see if I can open daxlib.org. Daxlib is a website where you can consume libraries. We can look for libraries, consume libraries, but in order to publish a library, publishing a library requires all the functions to be model independent, because this makes the function easy to use. We can just copy, we can just import this function. I can go add Power BI, copy, paste, or in other external tools, you can import the library directly. You don't have to worry about your model. The function can work. Of course, if there is some constraint, you will see in the documentation of the function what these constraints are. So that's the reason why this is so important. But this is also important if you want to create a library internally to your company without having to publish the library to the public like we do on DAXlib. There is only one problem. Now, if I want to use the range lookup, I have to provide 4 arguments. Think about this. So if I imported this function in my model, because someone provided me this library, now what I have to do, let's go back to my definition of the calculated column in price range min. Let's say that instead of using price lookup, now I want to use my new range lookup function that I define. Okay, so range lookup is my model independent function. What I have to do? Well, I have to provide sales net price, which is the value for the value that I want to search. Then I had to provide the table where I want to look for this value. Then I had to provide the column in this table that is min and the column in this table that is max. Okay, I mean it's not totally difficult, but this is verbose, right? So I have to write a lot of code, I have to write a lot of parameters, I have to pay attention to many details. Now assume for a moment that you will use this function in multiple places in your model. Now you don't want to write this code all the times. And so one idea is that when I have a model independent function that actually would depend on, where several parameters of the function actually depend just on the model structure of your model, on the tables and the columns that you have in the model, and not by the use that you want to make of that function. For example, in this case, by providing the sales net price parameter, which could be different in another table. Well, at that point, we could think about creating a model-dependent function based on a model-independent function. I'm not saying that we have to do this all the time, but we'll talk about this in a minute. So what do I mean with this? So, well, if I know that I have my range lookup function, and imagine that you imported this function from a library, for example, what I could do, I could create a function that I call, just to give a different name, price range lookup, where I have, in this case, only one parameter, my search value, just like, equal to, this is the syntax, equal to, search value is always passed by value, and the definition of this function will be, well, I want to invoke my range lookup function, the generic function that comes from the library, and here the first parameter could be search value, which is the value that I obtain as a parameter for price range lookup, but then all the following parameters, all the any ref parameters are just the dependencies that I have in my model. So for example, price range min, and price range max. So if I do that, now I made this function as easy to use as the previous function that I defined before, which was my price lookup. Again, if you only have one model-dependent function, you use this one, that's fine. We're saying if I have to import a function that is model-independent because I define this function in a library, I have this function in a library, and I want to create a version of the function that is easier to use, easier to invoke in my model, then it could be a good idea to do this extra function, range lookup. Price range lookup, this one. Because this one is as easy to use, we can see if we go back to price range min. If you remember, we wrote price lookup this way. Now, instead of writing range lookup, which is the direct reference to the function, to the model independent function, I can write price range lookup, and I just provide sales and net price. Result is always the same. We're not changing the result. This conversation about model dependent and independent function is just about what is the proper way to write functions. Where should I provide a parameter? Where should I not? Why should I expose more parameters or not? Remember, a model-dependent function is easier to use, is shorter, it makes life easier because we usually have a lower number of parameters. But the model-dependent function is harder to be used in other models just because it depends on many other details that you have to adjust in the model. So we typically use the model independent functions that are more verbose, that have more parameters, harder to use when we want to create code that will be shared across different models. So the model-independent functions, and just to make sure we have a reference when I talk. So a model-independent function is like this one, okay, range lookup. We use a model-independent function in libraries. Who creates a model-independent function? Advanced users, people who create libraries of DAX function for other developers. Okay, this is the primary goal for model-independent function. Who define and use model-dependent function? Model authors, just the model author for the function definition, and these functions are supposed to be consumed by report authors. So you might create a measure that is specific for a single report that uses model-dependent function because they are easier to use. They are shorter. They are, just easier to use. So now this is the main difference I want to introduce about the model-dependent and model-independent function. And there is another topic I want to show you in a second, which is what is the exact definition of a model-independent function. Let's talk about how to define the classic sales amount measure. The sales amount measure is a measure that internally has some particular business logic that, of course, in this case is very simple because if you look at the definition of sales amount, we simply compute a multiplication, quantity multiplied by price, for every row of the sales table. Now, when you look at this code, of course, you don't perceive the need of trying to reuse the code. The code is extremely simple, easy to copy and paste, no problems. But the idea is that if you think for a moment, there is a multiplication here between two columns, and actually this could be a much longer and more complex expression that uses data from this table, sales. Or better, a more complex expression that depends on a few parameters, like for example, a quantity and a price. So now I'm going to move this complexity into a function, knowing that the complexity is very limited in this case. But I hope that you can imagine that if we had to write not just one line of code, but maybe 5, 6, 7, 10 lines of code for a complex formula, that could be the case where we want to reuse the code in other measures, because this algorithm could be common to different measures, to filters in different measures, and so on. So let's try to move this calculation into a function. So if you create a function after that, what we could do is the following. So let's start with the definition. I copied in the clipboard this definition of sales amount. I go in my functions group, in my functions folder here, and I say, okay, I want to compute a sum amount function, which is at the beginning without parameters. Why not? And I just copy this. Okay, so if I do this, makes sense, and I can get this code and I can get the definition of sum amount, and I can replace my measure here, sales amount. Let me just comment this code at the moment. This code could be written this way, so by using sum amount. Now, I'm not fond of this approach. At the end of the day, if a measure is relatively simple, why not just write in the code in the measure? And if the function has no arguments, I don't really understand why this could be reused in other places, because basically you are reusing also the measure sales amount. So I would say that without an argument, this is not something I would like to see in a real model. So let's restore this one. Let's try to change this this function, doing something that is a little bit, let's say, more reusable. More reusable, perhaps in the same model, for example, right? Because, or maybe in other models, I don't know. Well, let's think about this. What I would say, any table that has a column called quantity and a column called net price, I might want to use the same algorithm. What does it mean? Instead of using sales here, let's say that I have a transactions table. Okay, transactions table is a table that I want to provide. And I provide this table by value or by expression. It doesn't really matter if I want to use this approach. Now, Of course, I use transaction table here, and at this point, I don't use any table name before the column reference. I know this is not a best practice, but if you think for a moment, this code, despite the despite the red line here, okay, is absolutely valid. This code is saying, for each row of the transaction table, I want to multiply the column quantity by the column net price. I know this syntax could be ambiguous because if there was a measure called quantity or net price, it would be interpreted as a measure. I know this is, I'm not fond of that. But if I keep the code this way, right? If I keep the code this way, and now I go back to my definition of the measure sales amount, I go here in sales amount, and let's create another copy of sales amount just to make sure that we want to make sure that we get the same result, right? So let's call sales amount 1. Okay, so let's just copy this measure also in the report so we can compare side by side sales amount original and the sales amount 1. And I replace this code with the invocation of sum amount. Okay, sum amount is my function, and I provide sales as a parameter. So my transaction table is sales. You see, I'm not specifying quantity and net price. And quantity and net price could be in other column, in other tables, and I could provide the name of the other table. It would just work because I'm specifying a column reference without specifying the table inside the function. And if I click enter, nothing happens. The result is the same. So the code works, and the function sum amount works. Remember, assume we have a much longer expression that justifies creating a function, not just a multiplication. But this is enough to start to make a few considerations. For example, first question, is this a model dependent or model independent function? If I go to the strict definition of model dependent function, I would say this is not a model dependent function because I don't have a direct reference to a column, a measure, or a table of the model. True. But what am I doing now? I'm assuming that the transaction table has a column called quantity and a column called net price. And I cannot, let's say, enforce, let's say, the DAX engine or the editor to validate this in the measure that calls this function. So basically, what happens is if I provide a table name that doesn't have these columns, I get an error. Let's see. So if I go back here and I go in sales amount 1, and let's say instead of sales, I move, I don't know, product. Why not? The syntax provides an error. You see that there is an error here. So there is an error. The function generates an error saying the column quantity cannot be found or may not be used in this expression. But if you look at the code that you wrote, you don't see quantity because this is an error that is happening inside the functions, and you don't see the code of the function to understand what is going on. So for example, imagine that you had multiple arguments and multiple tables as argument. Which table are we talking about? Do you expect this quantity to be in the first and the second or in the third table that I provided you as arguments? I have no idea. So that's the reason why I would say that while this approach is possible, you can write this code. This is valid code from a DAX standpoint. As long as you use it the right way, it works. But we consider this code model dependent, not model independent, right? Why? Because if we see this quantity and this net price column, they should exist in the table. So there is a dependency on something that is in the parameters. Okay, so it's a, let's say, an indirect dependency that we have, which makes this function not qualified to be published on daxlib.org. So if a function has this code, you cannot publish on daxlib because it is too complex to be used. There are too many details to know, and we want to have functions that are easy to use. Again, this is just a decision of daxlib. You could do this, but we should find a name because I understand that this is model dependent or model independent. It's something in the middle, okay? But it is not completely model independent. So because it is not completely independent, we classify it as a dependent. So how do we make this usable? Because now the problem is, how do I make this usable? Well, technically, I can just say, look, if these other two columns becomes references, then this could work. Let me show you. So let's create another function. I start from this one. I call this sum amount independent, okay? And I just want to replace this column with a reference. So this will be quantity column. And this will be any ref exp. In this case, remember the suffix column says this is a column reference, okay? Reference, column reference. And so now I use quantity column here, and I do the same for the price. So the price column, not net price, just price, because generically this is a price that we want to provide, is any ref exp, okay? And I use price column here. Now, at this point, we also want to expose transactions table by expression, just to make sure that we clarify that everything is moved by as an expression, because otherwise it could be unclear that we want to use this as column reference. It's a long conversation. I mean, it could work in several cases, but my suggestion is that you want to move also the table by expression in this case. Now, if I do that, this is a new function that works, and if I go to the definition of the measure, sales amount 1, so let's restore sales amount that works with sales, okay? Let's create a sales amount 2 measure, just because we want to make sure that we create something that works. So now I keep the same, but I will change in a minute. So let's fix the decimal number and decimal number, so we have the right formatting. Then I go back to sales amount 2, and in sales amount 2, I want to use the independent version. Now, the independent version, once again, we have more arguments. We have sales, we have quantity, we have net price. Okay? And this way, I am using the function that is model independent. This function could be published in a library and so on. And of course, once again, if we want to make this easy to use in my model, at this point, not just these two, but the three references could be included in a function that I will use only in this model. So in other words, what I'm saying is that I could use this invocation here. I could create a function that exposes this. So I call this function, for example, sum amount model, because it will work only in this model. At this point, this will not have any parameter, and will just be a placeholder to invoke the sum amount independent version with all the parameters, which are the references that we have here. If you remember the previous example, again, in this case, I don't know if I will create a function, to be honest, but if this was a more complex independent function and I can reduce the parameters from 4 to 1, from 5 to 2, I will probably do that, because I will make it easier to use the function in the model without having to remember all the parameters and making it easier to read. So that's the reason why we create these model dependent functions, to make it easier, the consumption within the same model. And so in this case, I can create another measure, sales amount number 3, just to make sure that we have everything correct. So this is the sum amount model, which is the last one I created, no parameters. I just change the format, I move this here, just I want to make sure the result is over the same. I know, the example is very, very simple, but this was a way to show how these functions can be defined and used in a very simple environment. In the real world, we have many more lines of code, many more parameters, and that's the reason why if you start to realize that the complexity behind this word, I think we understand that we have to follow a few rules. As long as you create the function for your model, you can do whatever you want, but if you want to create functions that you will reuse in the future or you will distribute to the other users, it's a good idea to follow a few naming conventions. What does it mean? For example, if you look at the functions I created now, I mean, all these functions, and let me zoom this a little bit. All these functions have a name that, I mean, yes, I added model and independent, but I don't want to do this all the time. And if I look at the function that I created in the previous part of the example, price lookup, range lookup, price range lookup, I have no idea. Just looking at the name of the function, I have no idea whether they are model dependent or model independent. So that's the reason why, and I want to show you a few information about the naming convention we have on our website, that it could be a good idea to follow these naming conventions to distinguish between model dependent and model independent functions. For example, for the model dependent function, we could just use the function name like we did, or we could use a prefix like local dot, so that we make sure that this function is for local use only. At the same time, when a function is model independent, it should always have something with a dot before, so a prefix, which identifies the library name, for example. So like, for example, in this case, math.sum2numbers, where math is the library name, or math.common.sum2numbers, because inside the library math you have also a group of functions that is called common. Or you could have your company name as a prefix for all the functions that are shared in your company. So that's the idea. The idea is that if we have something that makes the function immediately recognizable, we understand whether it's a model dependent or a model independent function. And for example, in your model, if you want to use in measures only model dependent functions, you will just use local dot, right? So this is an idea. But again, the important part is that how you expose them. Then consuming, I mean, nothing stops you from consuming a model independent function from a measure. That's not a problem. But when I have a list of functions, I want to be able to understand what is going on in these functions. Similarly, for the parameters, and I already mentioned this before, it could be a good idea to use a naming convention using a particular suffix, like column, table, measure, for the parameters that I provided by expression, and because we want, when we read the parameter, we want to, when we read the parameter into the function code, we want to understand what the parameter is supposed to be. For example, if we have a measure reference, we know that there could be a context transition if there is a row context. And if we just have a name A, B, C, it's hard to remember that, oh, this is a measure, this is a column, and so on. So having this suffix helps reading the code in the function code for humans. Okay, the machine has no problems for that. And we also suggest to use camel case for parameter names. Camel case means that we have a list of words. The first one has a lowercase and the other one have the first letter uppercase. And this is a naming convention, camel case, that if we use only for the arguments of a function, for the parameters of a function, we will recognize the difference between, for example, a variable name, usually Pascal casing, like a table name, usually Pascal casing. So these are small details that can help in reading the code of your functions and in consuming also the functions from your code. So we have seen several details. When you write a DAX function, you should think about you write a model dependent or a model independent function. You might want to write both, but again, it's something you have to be aware. And you also have seen the importance of naming conventions for function names and parameter names. This is important in the long term to make your code easier to maintain and easy to use for your functions. Enjoy DAX!